Hello everyone, in this tutorial, I'm gonna show you how to create an umbrella using only geometry nodes, without any other modifiers. The umbrella we are going to make is composed of a shaft, a runner, ribs, panel, and tips. First, let's start with the ribs. The runner is the black object moving along the green shaft. When the distance from the bottom of the shaft to the runner is defined as x, the angle between the shaft and the pink rib can be calculated using the following equation. Once rotated by this angle, the two end positions of the pink rib get to be determined, which subsequently determine the positions of the other ribs. Firstly, the starting point of the cyan rib is positioned at the top of the shaft, and the end point is located at a specific internal point of the pink rib. Secondly, the starting point of the orange rib is positioned at a specific internal point of the cyan rib. The end point of the orange rib is determined in a way that ensures both ribs are parallel, and the orange rib matches the length of the pink arrow above. Lastly, we can make the blue rib go through both ends of the orange and pink ribs. Let's take a look at the nodes for this umbrella. This is the overall node setup for this umbrella. Let's start with the node setup for the ribs. I made a node group, geo.rib, which creates not only rib but also shaft. This node group takes start and end positions as well as a rotation angle as inputs, and returns both the curve and the lofted mesh of that curve. Let's see the node setup for the pink rib. The group input, runner, takes values between 0 and 1, so the product of the runner and shaft length represents x. And the rotation angle for the pink rib can be calculated by just connecting some math nodes. Next, this is for the cyan rib in the picture. The end point of the cyan rib is positioned at the certain internal point of the pink rib. And we can get the internal position using sample curve node with a specific factor which is defined as a group input. This is how the position of the endpoint changes according to variations in this factor value. As the factor value increases from 0 to 1, it returns a position between the starting point and the end point of the pink rib. For the orange rib, in order to create the orange rib parallel to the pink rib, I made a node group which returned the direction vector of the input curve. Finally, to get the end position from a curve, I used sample curve nodes with factor 1. By performing vector operations with these positions, we can determine the start and end positions of the blue rib. Before we scrutinize the node setup for the panel, let's briefly touch upon the remaining parts. Making a runner, tips and an end tip involve simply placing cylinders at specific positions and rotating them, thus they do not require additional explanation. Therefore, let's proceed directly to the panel. To create a panel, there are three main tasks that need to be done. First, preparation of a profile curve and the loft of that curve along the z-axis. Second, axial and radial modification of the lofted mesh. Last, interpolation between two profile curves to imitate opening and closing an umbrella. Let's take a look into the node setup for the panel. To obtain profile curves, a node group was created to return the endpoints of the input rib. The role of the is pin checkbox here is to select the part that gets fixed to the rib when the panel opens and folds. So far, what has been obtained is not the profile curve itself, but rather a prepared point group with known order. By using the sample index node, each vertex and curve line gets to be placed at the same index vertices in the point group. Now that the profile curve is prepared, let's explore how to perform lofting around the z-axis. To apply the previously obtained profile curve to the curve to mesh node in Blender, it needs to be positioned on the XY plane. Therefore, it is necessary to rotate and then perform a parallel translation on the obtained profile curve. Please note that the radius of the curved circle and the absolute value of the translation along the x-axis of the profile curve must be equal to each other. Next, let's look at the interpolation of profiles. In the profile curve, the vertex at index 1, which is not pinned, should move away from the rib as the umbrella opens. When the umbrella is fully open, the vertex at index 1 should be positioned at the midpoint between the vertices at index 0 and index 2. A vector mix node was utilized to interpolate between the midpoint obtained in this manner and the original point. The runner was appropriately map ranged so as to be applied to the factor. Now that the lofted mesh for the panel is ready, it is time to modify the mesh both axially and radially in order to imitate a real umbrella. First, it is the sagging of the panel between the ribs. Second, it is the protrusion of the panel near the ribs. Before that, flipping index is important for the easier modification. Right after loft, the obtained mesh has radially increasing index for its vertices. By flipping index, we can use the axially increasing index. To avoid confusion, the index for the mesh cannot be changed, but we can simply use the calculated flipped index. In order to flip index, we have to know the axial and radial resolutions for this mesh. I made a node group for the constants for this umbrella. Using modulo operator and division operator, we can flip index, and also acquire the radial axial 2D coordinates. This can also be utilized as UV coordinates for shaders. From now on, I'm going to briefly explain how to create the sagging of the panel. The meaning of the output from the mustard-colored math node is that, when progressing axially from one rib to the adjacent rib, it increases from 0 to 1. Applying the following float curve to this value achieves the implementation of the sagging. The magnitude of sagging of the panel increases in the radial direction. So, with the relative radius, which can be obtained from the radial coordinate divided by the radial resolution, we can apply the radial weight on the panel for the sagging. Last, it is the protrusion of the panel near the ribs. Similar to implementing sagging, I used a symmetrical float curve for the magnitude of the protrusion. However, contrary to sagging, I made the weight decrease as it moves away from the center. This is the end of this tutorial. I hope you found this tutorial helpful. Thank you for watching. I'll see you guys very soon. Later.